you're good at it.
I'm really, really good at it.
At bowling?
No,
Oh.
I'm good at bowling though.
Well, if you're going into, what are you going into?
I know.
Air Force?
I suck at bowling.
Okay.
I'm alright. You saw that? The highest I've gone is 150.
Everyone should have found on their desk a paper plate, markers, a protractor, and a ruler.
Yeah, this is the boys' side. Don't get over on the girls' side. This is only
Rachel's in
boys'.
the middle.
This one's separate.
Game.
Today we are creating a unit circle. So the first thing we're going to do is take your plate and fold it in half. So that when you open it up, you can see a line. Did I give you pencils instead?
No.
Oh, okay. So I'm going to trace that line in one color.
Just the inner circle?
Yes, just the inner circle. We're going to leave the outer part of the plate to do some writing on. And then I'm also going to go ahead and at this time I'm going to trace my circle.
We do it upside down.
You may do it any way that makes your heart happy.
I don't know which one.
Yeah, I tried it a couple of different ways and
Okay, whatever. I give up. I'm making that circle already.
okay, so the next thing I'm going to do is I'm going to put my other axis in, but here's what I discovered. If you try and fold it again, you end up off by just a little. So instead we're going to use our protractors. And your vertical axis should intersect your horizontal axis at a 90-degree angle. So I'm lining my protractor up. You want to get it in the center is the only thing. So I'm going to make a mark where 90 degrees is.
How can you tell if you're like too high or too low? Oh, you can measure it.
Yeah.
What's that second dot for?
I just made 2 dots for my line. So then I'm going to use my ruler to put my vertical axis in. So we should have something that is pretty close to perfect quadrants.
I got 5 and 3.
Okay, then you need to be a little more than 2.5 for your radius. We are going to start with putting our quadrantal angles in here. So those are the ones that we talked about yesterday that fall on our axes. So we start with 0 degrees, 0 radians. And we said yesterday that a coordinate point on this end would have 0 for its y. And we said that its x would be equal to the radius of our circle. But the radius of our circle, because this is a unit circle, is 1.
That's enough for all mine. Weird.
I see.
It was not good. Like, all.
It'll be close enough. It's okay. So our next quadrantal angle was 90 degrees,
Are you recording now?
or pi over 2. Yes, I am. Thank you for reminding me.
No, I was just saying because like the numbers on.
Oh, that's because I'm not recording using the camera app. I'm recording using my browser.
The what number?
The number is at the bottom.
Oh,
Now the point here, my x is 0 because I'm on the y-axis. And my y is my radius, which again, in the unit circle, is 1.
wait, so. The pi and number is zero, or the zero, that's it?
Mhm.
Okay, so that zero is the radian, and that's the degree.
Correct. Now if we continue to our next axis, this is 180 degrees, or pi radians. It has a coordinate point of -1, 0.
I bet if we play with the next zero,
Good. At the bottom, our point is going to be 0, -1. My measurements are 270 degrees, 3 pi over 2.
35.
Yes. That brings us back up to our positive x-axis. We've now completed the circle, so we have gone 360 degrees, or 2 pi radians. And that completes the quadrantal angles. Questions so far? Okay. We are going to do 45-degree angles next. So I'm going to start with drawing my angle in. I'm going to take my protractor. And I picked my colors. I'm just going to, explain my thinking real quick. I picked my colors so that my 30-degree angle and my 60-degree angle are in the same color family, but are still different colors. My 45-degree angle is a contrasting color, if that makes sense.
Are you using purple?
Blue,
Oh.
and then I'm gonna use a red and a pink. So let us imagine that we put a 45, 45, 90 triangle into our first quadrant. So I'm going to mark 45 degrees here. Here we are. 45 degrees. And then I'm going to use a pencil and draw in the third side of my triangle. Mostly because the triangle is not technically part of the unit circle, it just explains how this works. Yeah, sorry, pencils are the one thing that I didn't provide. It is your circle. You do what works for you.
Well, what if we don't want to do our circle?
You have to do your circle. That is an excellent question. Okay, so this would be a 45, 45, 90 triangle. And because this is a unit circle, I know that my radius, which is my blue line here, is 1 unit long. Well, the ratio for a 45, 45, 90 is x square root of 2.
I remember that.
Good. So what I know is that x square root of 2 is equal to 1. Okay, that's my hypotenuse, and I set it equal to 1.
Oh, because the circle itself is like the radius.
Good. So that means that x is equal to 1 over the square root of 2. But this is like the one time that I actually follow the rules and rationalize, is the unit circle. So I find that each of my legs have a length of square root of 2 over 2 units.
Are we supposed to be writing?
You don't have to. I am explaining to you where the numbers that we are about to write down come from, so that it's not just magically Mrs. Festerman gave you numbers. Okay? So this means that each of my legs has a length of square root of 2 over 2. So that means that my length here along the x-axis is square root of 2 over 2. And my height here, my vertical height, is also square root of 2 over 2. So this point here has a coordinate square root 2 over 2, square root 2 over 2, because those are the lengths of my legs. My angle measures, well, we already know that in degrees it's 45 degrees, right? Because that's how we drew it. In radians, that comes out
Oh, we get
pi over 4. And here's how we get there. It is halfway between 0 and pi over 2. So I cut pi over 2 in half and get pi over 4. Okay?
Oh, okay, so a half a circle is 1 pi, and then, half of that is pi divided by 2, and half of that's pi divided by 4, and so on and so forth.
Exactly. So now,
What happens if I just make 100 on this? And you're done? First round.
you're done.
Do I get to-
Sure, I'll bring you a cookie. Okay. So from our lesson on reference angles, recall that every angle in our circle that has a reference of 45 degrees is going to have the same coordinates. We're just going to change the sign. So we can trace this line that we have here into the third quadrant.
I forgot we had these.
And that point will be negative square root of 2 over 2, negative square root of 2 over 2. Because everything's negative in the third quadrant. Then, sorry, let me know if I move too fast. I'm going to measure out a 45-degree angle in the second quadrant.
And that's a 90 degree.
So I have a blue line that bisects the second and fourth quadrants. In the second quadrant, my x is negative, but my y is positive. And in the fourth quadrant, my x is positive, but my y is negative. So that I now have points on all of my blue lines, or whatever color you're using. So now it's time for the angles. Okay. Well, I started with 0, and then I added 45, so I got to 45. Plus 45 is 90. Plus 45 is 135. Plus 45 is 180. Plus 45 is good. Plus 45 was 270, so plus another 45, 315. So those are our degrees. Now let's count pi. Pi over 4. I'm gonna use a trick that I learned from another teacher, and I'm gonna write these in pencil to show you how they work, okay? So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So notice that my quadrantal angles reduced down, right? That's why I want them in pencil, because I want the reduced form there. But on the blue line, they don't. So I end up with pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.
Oh.
And those are all of the pi over 4s. So next, let's talk 30 degrees. So notice all the angles we're doing are special angles, right? So in the first quadrant, I'm going to repeat my process from earlier. Except for this time, I want a 30-degree angle instead of 45.
Oh, man. Yeah.
And so this is going to represent a 30-degree angle. And again, I have the ability to turn this into a 30, 60, 90 triangle. Okay. Where my 30-degree angle is down here in the corner. And I already wrote my 30 degrees up here, but in my triangle, this would be my 60-degree angle. Okay, but we're just going to work off of the 30. So 30, 60, 90 triangles are X, X square root of 3X, 2X. But in this case, again, I know that my hypotenuse is 1. So 2X equals 1, which means X is 1/2. So the sides of my triangle are 1/2 square root of 3 over 2, 1. Where 1/2 is across from 30. Okay. Smallest angle, smallest side. So if this is 30, then across from 30 is my y. Yes?
What?
If my 30-degree angle is down here in the corner, then my y value is across from 30. Do we all agree with that? Okay. So that means the y value of my coordinate point is 1/2.
Does that say 30 degrees?
30 degrees, yes. Because this line represents 30 degrees.
Oh, I thought the 30 degrees was, I thought that was 60 degrees.
In our triangle, it is.
Oh, okay.
But
so
for our
it's in
circle, we're going to label that line 30.
the line, not the angle.
Correct. The line, not the angle. So if my y is 1/2, my x is square root of 3 over 2. Because that's the other side of my 30, 60, 90 triangle.
No, I said that this would be easy for me to understand.
There are tricks.
Error was all over.
There are tricks. And honestly, if you can memorize the first quadrant, then it's just a matter of remembering what signs go where.
That's what I was thinking, but I don't know about this 36.
Just-
Alright.
Just have a little faith in yourself at this point.
What's that thing? The X and Y value?
Square root of 3 over 2, 1/2. The radian measure that is equal to 30 degrees is pi over 6. Okay, so in the third quadrant, my coordinate point, negative square root of 3 over 2, negative 1/2. Then if I draw it into my second quadrant, I know that in the second quadrant, I'm going to have a negative x, so negative square root of 3 over 2, and a positive y, so a positive 1/2. And in the fourth quadrant, I'm going to have a positive x and a negative y.
I'm starting to notice the pattern. A little bit.
Good. So if we use 30 as a reference angle, we can fill in our angles. 180 minus 30 would be 180, 150. So this is 150 degrees here. 180 plus 30 is 210. And 360 minus 30 is 330.
I got so scared that I was wrong.
I'm going to give you the radian measurements for the moment, and we can talk about how we got there after we've put in our last angle. So this is 5 pi over 6 in the second quadrant. In the third quadrant, we have 7 pi over 6. And in the fourth quadrant, we have 11 pi over 6.
What was it in the first quadrant?
First quadrant, it's pi over 6. Do it one more time. So I'm switching to a related but different color because 30 and 60, which is what we're going to do next, are two angles in the same triangle.
I agree.
So let's start with putting our 60-degree angle in. And I'm going to go ahead and extend my line all the way through into the third quadrant. Just to save myself some time in a moment.
What? Oh, no, it's wrong.
It's line.
So this line represents a 60-degree angle. Which in radians is pi over 3. Now, in this case, if we drew our triangle in, triangle, right there. My 60-degree angle is now down here at the bottom. And the side opposite 60 is square root of 3 over 2. So my y value is going to be the square root of 3 over 2. Which means my x value is 1/2. In the third quadrant, both of those numbers will be negative. So I'll have negative 1/2, negative square root of 3 over 2. Square root of 3 over 2. And then we put one in the second quadrant and carry it through to the fourth. So in the second quadrant, we have a negative x. So it's negative 1/2. And a positive y, so positive square root of 3 over 2. And in the fourth quadrant, we are going to have a positive x, so positive 1/2, and a negative y, so negative square root of 3 over 2. So let's talk angles. 180 minus 60 makes this line up here 120. $180 plus 60 gives me 240. And then 360 minus 60, 300.
Which one is it?
120 is in the second quadrant.
I think I did this one. Oh, yeah.
It's okay, you can have this one when we're done. So then the radian measurements, well, we can count this out, 0, pi over 3, 2 pi over 3, 3 pi over 3 makes a pi. Add another one, we're at 4 pi over 3. 5 pi over 3. And then one more makes 2 pi. Now, seeing as these are yours, you're welcome to make any notes on them that you would like to, but one thing that I would definitely recommend making a note of is that in your coordinate points, you're looking at cosine, comma, sine. So for example, the cosine of 315 degrees, I would find 315. It's my x coordinate, so the cosine is square root of 2 over 2. So I will include the first quadrant of the circle on your 3-week test next week.
You have to figure out the rest.
If you can, no,
Oh.
let me rephrase that. Thank you. I will test you over the first quadrant on your 3-week test. If you can do the entire circle, you're exempt from all following unit circle quizzes.
Wow. We got 4 weeks, right?
Yes, which happens to fall over Christmas. So, I'm sorry. It was just the way that the timing worked out this year. So my advice is to try and have it done either next week or the week after, so you're not quizzing when we come back from the break.
Okay.
We only have 6 minutes left in class, so on Monday, I will share with you some of the tips and tricks that I use to help me remember the circle. Though some other excellent resources is if you are friends with anybody who took pre-cal last year, some of them came up with some really good ways of memorizing. And congratulations, you get a 300 for participating today.
Yay.
I'll take it down.
And I give.
Wait,
David, I was